study guide page 2. So this one requires a little bit of factoring. We're given this function here, y equals x to the 4th power minus 6x cubed minus 7x squared. Before we begin anything, we always have to check to see if we can factor anything out of this equation, out of the right-hand side. So let's put an invisible 1 there. So if I'm looking at my numbers, I'm looking at 1, -6, and -7. And if I think to myself, none of those have any common factors. But now if I'm looking at my x's, I have x to the 4th power here, I have x to the 3rd power here, and I have x squared here. Now if I look to see the common variables they all have 1x, and then they all have another x. Oops. So 2 x's that we can factor out of each one of these. So we can factor out an x squared. So now, if we factor out an x squared, so we're taking x squared out of each of these, that comes outside of the parenthesis, and then we start seeing what's left. So if this is 4x's here, we take 2 of them out, so we have x squared left. This second term, we have a -6, and then we had x cubed, oops, this is x squared, -6. We had an x cubed and we took 2 of them out, so just x is remaining. And then the last one, we just have a -7. -7b remaining. Now we can start figuring out what our zeros are, and we have to factor a little further. So if we're looking at this here, it's a quadratic, and our a is equal to 1, which means we can go and do the diamond. So if we do the diamond, -7 goes on top, -6 goes on bottom. We figure out what multiplies up to -7 and adds to -6. That's going to be -7 and 1. So this parenthesis, the quadratic in the parenthesis here, is going to factor into x minus 7 times x plus 1. And remember that we had that x squared on the outside. So here's my x squared that I'm bringing down. Now I want to start figuring out what my zeros are. So the first thing we're going to do, we have x squared equals 0. Then we have x minus 7 equals 0. And finally, we have x plus 1 equals 0. And if we're simplifying all these out, this is going to be x equals 0 with the multiplicity of 2. If we add 7, we get x equals positive 7. Subtract 1, we get x equals negative 1. So there's our zeros. So our zeros are x equals 0, multiplicity of 2, x equals 7, and x equals negative 1. And as coordinates, that's 0, 0, 7, 0, and negative 1, 0. So now we can go ahead and put our points on the graph. There's 0, 0. I'm going to say 7 zeros over here, and negative 1 is right there. Now finding the y-intercept. Remember the y-intercept, we always plug in 0, and we're going to plug it into the equation here. So if you do plug in 0, you end up with 0. Everything zeros out there. Now our end behavior. So I'm looking down here now. So we look at our leading term. We have x to the 4th power, which means our endpoints are both going the same way. And since a is positive, it's a positive 1 in here, it means that they're both going to be opening upward. So as a reaches positive infinity, then y is going to infinity, and if as x is reaching negative infinity, y is reaching positive infinity. So if we were to graph these, you know the endpoints are going up and up. So this is going to end up going up and up. At x equals -1, there's no multiplicity, so we go through. At x equals 0, we have a multiplicity of 2, so it bounces. And then at x equals 7, it goes through. And there's our graph. Now this next one. So got to start the same way. You have to see what can we factor, or if there is a factor. We look at 4, -17, -15. 17 is a prime number, so we can't factor anything out. But if we look at the x's, we have x cubed, x squared, x, so we can at least factor out an x out of all these. So first we'll have to factor out this x, which leaves us with 4x squared minus 17x minus 15. Okay. So this is a quadratic here, so it can be factored further down. Since we have a greater than 1, right? A is 4. First step, we got to multiply this out. So we'll have x in parentheses, x squared minus 17x, and then -15 times 4 is a -60. So now that a is 1, we can do our diamond. What multiplies up to -60 and adds to -17? We are looking for -20 and 3. So when we rewrite this, this turns into x times x minus 20 times x plus 3. So we're almost done here, but remember up here in this step when we multiplied by this 4? In this step, we have to undo that multiplying by 4 by dividing this 20 by 4 and dividing this 3 by 4. So now this x I'm bringing down, this fraction here, if we can simplify it, we go ahead and simplify, or if you can reduce it, go ahead and reduce it. But 20 divided by 4 gives us 5, so this is x minus 5. And I'm looking at the right fraction here, 3 divided by 4. It doesn't divide evenly, so we're going to shoot this 4 out in front. So it'll be 4x plus 3. Now we got to find these zeros. For that x that's alone on the outside, it's just going to end up being x equals 0. There's no multiplicity there because there's no exponent. Now for this one here, we're going to set x minus 5 equals to 0, add 5 to both sides, and then we end up getting x equals positive 5. And for this last one, the 4x plus 3, if we take 4x plus 3, set it equal to 0, subtract 3, we get 4x equals -3, divide by 4, and we get x equals -0.75. Okay, so now that gives us all our zeros. So for the zeros, we can write in x equals 0, x equals 5, and x equals -0.75. So we don't have any multiplicities for any of these, so they shouldn't be bouncing. The x-intercepts will be 0, 0, 5, 0, and -0.75, 0. So here's 0, 0. I'm going to say this is 5, 0, and then -0.750. It's pretty close. Now the y-intercept, if we plug in 0 in for x, 0, 0, and 0, everything's going to 0 out, so it's just 0, 0 for y-intercept. So y-intercept is 0, 0, 0. And now end behavior. So we're looking at this term here. Our leading exponent is an odd. It's 3. It's odd, which means our endpoints are going different directions. One's going up, one's going down. And since it's positive 4 out in front, then we know when we graph this, we start with our graph going down this way and up this way. And remember that we had no multiplicities here for our x's, so all these are going to be going through when we draw it. So goes through, comes back, and then goes through and meets the endpoint. So as x is reaching positive infinity, then which is this way. So as x is going this way, our graph is going up, so towards positive infinity. And as our graph is going to negative infinity, our graph is going down to negative infinity.